Hi everyone, this is Bob from the Netskope team, and I'm very excited to give you a live demo of the Netskope Zero Trust Engine. Now, I get a lot of questions about the Zero Trust Engine. It's in all of Netskope's marketing material. It's on our website. It seems like it's every conversation that I have with customers and a lot of Netscopers have with customers, because the Zero Trust Engine is really a central part of the Netskope One platform. And it's very critical. If you think of the Netskope One platform as this unified platform where users and devices, wherever they are, as they're accessing destinations, everything goes through the Netskope Zero Trust Engine. And what happens is every one of these real-time transactions gets basically processed and decoded, and rich context is derived from that transaction that helps you not only get a better understanding of what's going on with regards to risky activities, sensitive data movement, potential threats, but also it helps you inform a more effective policy decision. When you're making a kind of a zero trust decision, it's the signals and context that really drive that better policy decision. So think of all of the context in real time, from identity, device posture, the location of the user, the location of their destination. What is the destination? Is it a risky destination? Is it the corporate versus personal or a partner instance of an application? What activity are they performing? Are they just, browsing the application? Are they logging in? Are they performing an activity that could lead to data loss or potential threat? And also, what is the overall behavior of the user that is performing the activity? Maybe it's they're exhibiting behavior that is of malicious intent, or perhaps a user that has had their account compromised. And then ultimately, is there sensitive data part of the transaction? So all of this context really informs the policy decision that you want to make. Maybe it's you don't do anything because it's a benign and you allow it to happen. Maybe there's a very risky scenario where you're going to block it, or there's decisions in between where you safely enable it by putting in guardrails. Okay, so let me take you through some examples of what that looks like in the real world. The first thing that we're going to go ahead and do, let me switch back over here, is I'm going to log into my Netskope console. Because what I want to do, I think it makes sense to start with the unified policy engine, kind of the real-time policy engine that governs all of the traffic going through Netskope. So I'm going to go to Policies, Real-Time Protection. And let me start with a common policy here. So here's a policy where we're going to bring in two areas of context. We're going to bring in identity, and we're going to bring in the device classification. So this is a very common scenario where you have a corporate resource that's hosted either in your data center, maybe it's in your private cloud. And what happens is this is typically a job for a VPN. But in the case of a Netskope One platform, we're invoking zero trust network access. So much better way of doing it. But it's the signals and context that inform whether you want to grant access to this resource or not. So by default, you would block all access except for people in finance that are on a corporate managed device in this example. So what happens is, if I'm a user, and let's put on the user hat, and by the way, I have a Netskope client deployed, so all of my traffic as I go to private applications, I go to websites, I go to SaaS applications, I go to different internet destinations, all of that traffic is going through the Zero Trust Engine. But what I'm going to do is I'm going to go ahead and go to a private application. And if I actually open up my Netskope client here, you could see my identity. It's Bob at bobsbank.net. I am on the finance team. And also you could see that my device classification is a corporate managed device. So it's detected that my device has maybe the CrowdStrike endpoint running with the latest version. It's got encryption enabled on the device. Maybe there's a presence of a certificate. All of these different elements determine whether it's a managed device or not. So I am on a managed device. I have the right identity. So now what happens is if I go to access this application, it's already cached by credentials. Usually it would pop up with, Okta in my case, but it could be, Entra and et cetera, et cetera. But right now I have fast and secure access to this private application. It's going through Zero Trust Network Access. We verified basically the identity, device posture. Now, what happens if the user turns around and they try to access a application for which they do not have privilege? So, hey, notice you're not on the engineering team. What are you doing? So we're able to basically govern that as well. Okay, so that's going to a private application. What I want to go ahead and do is let's switch to some more advanced use cases. Let's say it's not only a SaaS application, but it's a generative AI application environment. And we have live demo videos on YouTube. You could see about our whole way that we secure genAI. But what I want to show you in the context of a Zero Trust Engine is what I'm going to go ahead and do is I'm going to start by opening up Google Gemini, because we've all been here. This is a very common use case, and this is the corporate instance of Google Gemini. If I go up my upper right, I'm logged in as my Bob at bobsbank.net. Now, this is important because since this is the corporate instance, basically it's licensed by, in this case, Google. Google provides assurances that data that users put here will not be used for training. That is one of the big challenges with generative AI app adoption. The challenge here, though, is I want to get all my employee population to use this, right? Because it's the safe one. But what happens is most people in the organization use an instance that is not the corporate instance. A lot of times they either sign up like this user has with their personal Gmail. There could be thousands of employees that do that. Or in many cases, you don't even log in. You can actually still access these applications and send data to the prompts, and even if you don't authenticate. And that data, because it's not the corporate license, will be used for training. That's the scary part. So here's what Netskope does. So I'm in the personal instance. The challenge here is if I look at the URL up here, gemini.google.com, I'm in the personal instance of Google Gemini. This could be Copilot, it could be ChatGPT, kind of the same effect. What happens is if I go to the corporate license, it's still gemini.google.com. So the problem here is if you start out as a firewall or secure web gateway and your world is all about URLs and domains and web traffic, you're not going to be able to discern the difference between a corporate and a personal instance. So now you're limited to kind of tenant restrictions and coarse-grained policies, allow versus block. Ugh, right? Not a good approach. Netskope is much smarter than that. So here I am, and again, in the personal instance, it's gemini.google.com. If I take this document here, it's a patent draft, very sensitive data, and all I want to do as a user, I'm not being nefarious, I just want to get a summary of this very large patent draft. Netskope in real time, not only did we detect that it's patent data, we use AI to do that, but also we detected that the destination is a personal instance of Google Gemini, even though the URL is the same. So that's the smarts of Netskope. So the adaptive access control basically changed it from a block to allow because it is, in this case, from an allow to a block because it is a risky destination that would have been used for training. So now the user, they're not being nefarious. They say, oh, okay, sorry, I'll go ahead and use the corporate instance, and they basically ask for a summary of this document, and now the block dynamically changes to an allow. This is the adaptive access control based on the app instance awareness and the sensitive nature of the document. So the context plays a very important role from moving from kind of blunt force blocking or outright allowing to safely enabling, right? It's the guardrails because of the context. So let me give, it's not just the GenAI chatbots that this really serves an important purpose for. It's also the applications that have AI built in, right? And many of these different applications. Here's an example of Atlassian Confluence here. And what happens is traditionally secure web gateways and firewalls will show you that they can look at uploads and downloads and block data and all those things. The problem is that's like a 10-year-old use case. Everybody can do that. But that's not the way people work today. The people work in this app, what I'm going to do as a user is I'm going to go and I'm going to click on the create button. I'm going to create a live document. So I'm inside of the application and I'm going to say, hey, let's create a mergers and acquisitions plan because we haven't announced it yet. It's very confidential, but we're going to acquire Fabio Insurance. And what happens now is instead of people just starting and typing out a plan and putting their thoughts together, what do they use? They use the power of AI. So I'm going to do a / here, and I'm going to use the app's built-in intelligence. Now, this is, again, inside of the application, so it's AI, and I'm going to ask it to draft a plan about Bob's Bank plan to acquire Fabio. Very, very sensitive. This should not go to this application. This is where Netskope, our Zero Trust Engine, decoded that there is an AI post activity in Atlassian Confluence. This is the granular controls. And we detected that there's keywords like Fabio Insurance and acquisition and proximity of one another. That's bad. We shouldn't be talking about this acquisition. So we're able to use the Zero Trust Engine to basically govern that particular activity. So now what happens is if I go back to Netskope here and let's go ahead and go to scope it. Actually, let's go look at the policy that kind of made that happen first of all. So we're back in our policy builder. So a couple things that you'll see on the Gemini example, if we go to one of these policies here that I have, here was the one where we basically allowed patent data to go to the corporate AI instance. So in the destination, we defined the corporate instances of these applications, and then we tied it together with activities, and also we brought in kind of the patent data as part of that as well. So it's not just AI that we're kind of tailoring the Zero Trust Engine towards. There's could be thousands of these internet destinations. Let me give you another example of this. What I'm going to do is I'm going to go into AWS, right? Very, very popular. I'm actually going to go into EC2, right? So we're hosting a lot of these services in here. And a user, for some reason, has gotten basically overprivileged access to EC2. Somebody made an IAM configuration and they're in here. They shouldn't be. And what happens now is if the user goes in and wow, here's this service desk app that's used by thousands of people, and this could be disastrous. If I go in here in the console and I do stop instance, I'm basically bringing down this whole application for those thousands of users, right? That's horrible. Well, here's where Netskope comes into play. First of all, we detected that this user is not in the server admin group, so they shouldn't even be in here. And then we decoded that there is a stop activity inside of Amazon EC2. And because of the user's privilege, we blocked the activity. Now, what happens is if you're a firewall or secure web gateway, you're going to see 92 bytes go into AWS. You're not going to know that a user went into the AWS console and clicked on a stop activity. This is the power of the Zero Trust Engine, extending those controls to very, very risky scenarios. Now, I'm in the console here. What I'm going to go ahead and do is let me minimize my browser, because the next thing I want to show you is what if I interact with these services via the CLI? And this could be Azure, GCP, in this case, AWS CLI. All I did was get a list of S3 buckets. Pretty benign. So, you could see it here. But what happens next is the scary part. I'm going to issue a command to delete one of those S3 buckets. Now here in real time, the Netskope Zero Trust Engine decoded a delete activity in S3 and was able to block that activity and prevent that S3 bucket from being deleted. So even outside of the browser. So this is the example of effectively the granular controls, if you will. So now what happens is if I look at, and again, we're in the policy here. If I basically look at the policy, and let's see what, I think we got AWS as one of these. Let's go ahead and destructive activities. Here's an example of the policy for that instance. We're looking for destructive activities, and you could see all of the activities, even in just AWS that we can govern. It's 26 different activities. The Netskope Zero Trust Engine supports hundreds of activities across thousands of destinations. And then finally, if I go into Scope It, which is our event by event logging system, and what you can see here is basically a log of all of the activity. Here was the delete activity in S3. Yes, somebody tried to upload to this activity, this app as well. There's stop activities in EC2, a bunch of view activities. We saw the AI post activity earlier. So this is the power of the Zero Trust Engine, being able to do those adaptive access controls, not just identity, device posture, but also extending to contexts like app instance and activity, if you will. So what I'm going to do is we're going to switch a little bit from the Zero Trust Engine, those contextual inputs, to what about the behavior of the user themselves. So what I'm going to do is show you Netskope's advanced behavioral analytics system, where we have hundreds of behavior models. Many of these are AI powered. Many of them are also rules based. But the idea here is looking for behavior that is indicative of malicious intent. Maybe there's also accidental behavior. It could be also external threats. Basically, users that are triggering a bunch of malware events, phishing. They're visiting risky websites. They're moving data from corporate applications to their personal application. Maybe they log in one moment from Santa Clara, California. 5 minutes later, they log in from Korea. So there's impossible travel. There's all of these different models. And what happens is the models basically roll up into a behavior trust score. This is a big part of the Zero Trust Engine. It's like a FICO credit rating. You start at 1,000 and your score goes down based on anomalous behavior, risky activities. There is a decay, and also your score goes up with good behavior. Here I have a 0. This is a demo user, so he's been pretty busy here. Just even the stuff that I just showed you. So it's score 0. So now what you can effectively do is you can use that as a zero trust signal to inform a policy decision. So in the example here, what I'm going to say is if the user score is below a configured threshold, 351, we're going to treat them as a risky user, and we are effectively going to restrict what that user can do. In this case, we're going to isolate their session. So now I'm logged in as that risky user, and I go in and I try to access this website. Immediately you see this is all configurable, but the action I took is isolate. It's one of the many actions. I can coach, I can block, I can redirect, I can gently warn, I can force a justification. In this case, I'm isolating the user session. This looks like a risky website. But what happens now, because we're isolated, is if I try to click on links, for example, downloads are disabled. If I try to input, I can't input into forms, so we're preventing credential hijacking. Now, this is all tied to the fact that the user has a poor behavior trust score. So we're treating them as a risky user. So we're putting some more controls around that user. Okay, so that's one example. Now, what I'm going to do now is I'm going to show you another example. There's many different contextual elements, but I'm going to show you another one. This happens to be with a third-party risk. So what we're going to go ahead and do, let me see, I think it's, here we go. since we're talking about Fabio insurance acquisition, here's an example of collaboration apps. One of the great features of collaboration apps is you can invite external users into your application so you can collaborate. Think partners, vendors, etc. The challenge is once you invite them into your kingdom, you have virtually no control over the fact that that's an external user. What can they see or do or whatnot? So this becomes very important context that the Netskope Zero Trust Engine supports. Here, I'm saying if in this Slack account, if there's post activities that basically contain any information about Fabio Insurance, if those are in a channel that has an external user, this is the context that we bring in, we're going to prevent that from being posted. So let's see here if I have a channel. I'm going to go ahead and go into Bob's Bank Slack channel. I'm in a partner channel, and it does look like there is an external user here. So now if I go in and post something like Bob's Bank is planning to acquire Fabio Insurance, there's an external user. They should not know that. We haven't announced this, so that's kind of a no-no. So Netskope, because of that context, we were able to determine that that data should not be posted to that channel because there's an external user, and we blocked it, and we told the user, hey, there's an acceptable use policy, and why we blocked them, so we coached them. Again, in this case, the user may not have been doing that on purpose, so they switch over to the channel where they should be allowed to do it, because this is where we're discussing the merger, not the channel with the external user, and now the post is allowed, right? So this is the context, again, where you're removing the risk, right? At least reducing the risk, so you're safely enabling these applications through the use of granular controls and all of that risk-based context. Okay, so the last thing I'll show you is everything I've showed you is I have a Netskope client deployed. I'm sitting here in my home office. It's great because if I get on an airplane and I land, and I'm actually going to do this in Munich very soon, I land in Munich, those controls are going to follow me. But what happens if you have third parties, you have unmanaged devices where you can't put a Netskope client, but you still want to extend those zero trust controls to that environment? So one of the most popular deployment configurations is the Netskope One Enterprise Browser. And this is great because all of the existing zero trust controls, the DLP, the threat protection are seamlessly extended to an enterprise browser. So you basically give the enterprise browser to that third party that you, or that BYOD or that unmanaged device that you want to give access to your internal resources. So here I'm on a device without a Netskope client. It has the Netskope One Enterprise Browser. And if I go in and access something like this SaaS application, because I want to give access to this user, it's basically validating my credentials here. And now this is going through the Netskope One Enterprise Browser. I get access as a third party. And all of this is governed. So if I go in and try to access something I'm not supposed to, like this product roadmap, for example, what happens is Netskope extends DLP controls to that third-party access. And even if the user goes and tries to upload malware, maybe they're doing it on purpose or accident, we're also going to extend those existing controls to that unmanaged device. So Zero Trust Engine is also very applicable to third-party access, unmanaged devices. It's not just environments where you have a Netskope, client, or even a branch steering mechanism like IPsec GRE tunnels. We can extend it to these unmanaged devices. Okay, so that is the end of the demo session. Netskope Zero Trust Engine. Again, adaptive access controls that use signals and context to inform a more effective zero trust policy decision as users and devices are accessing these destinations. With that, I want to thank you very much and have a wonderful day.